4.2, congruence in triangles. All right, so on these, they tell us that for the first ones, triangle ABC is congruent to triangle TUV. And they give us the pictures of these two triangles. I'm going to do my best. So this is A, B, C. And this is V, U, T. And then they give us, this is 59 degrees. This is 55 degrees. Sorry, that's kind of tiny. And then this is 8 centimeters over here. So that's the distance there. All right, so then we're just completing the statement to answer the questions about these. So number 10, we have angle A is congruent to blank. So angle A is congruent to what other angle? T. 12. Triangle VTU is congruent to what other triangle? Make sure you know order matters.
CAB.
Yep, triangle CAB. So we looked at up here, it was ABC and TUV. They started with the last one and then started going over again, so we had to do CAB. 14. The measure of angle A is equal to the measure of angle blank, which is equal to blank degrees. So first of all, what is the measure of angle A? Like, what is that equal to as like in the other triangle? Not the amount, but yep. So the measure of angle T, obviously that kind of followed from number 10. Now I need to actually find angle A, angle T, whichever way you want to think about it. So how do I find that? What?
Add them together and minus from 180.
Yep. 180 minus the other two, so we would have 180 minus 55 minus 59. And, oh, let it do it for me. Okay, 66 degrees. Turn that off because it's annoying. Anyways. All right. These next ones are probably the most confusing thing because it's like you are listing off as much as you know about them essentially, so it's just kind of a lot. But they give you a picture or possibly two pictures depending on the problem, and they say identify any figures that can be proved congruent. So that could be angles, that could be side lengths, it could be the figure as a whole, and explain your reasoning. So it's almost like doing a proof, but you're not actually proving something, you're just like stating the reason, but it'll help you when you get to the proof. And then for those that can be proved congruent, write a congruence statement. So I'm going to do one that's a little easier and then one that's a good bit harder. So number 16, I've got, it's probably going to make it a rectangle, yep. Okay. All right, good enough. All right, and then these markings that I'm putting on here are the markings that would have been given to you in the book. All right, so this is what it would look like. as you are doing that. All right, so we're looking for what things we can prove are congruent. Okay, so anytime I have an object that is like a shape that's like split in two, like this one is, because I know that this side is congruent to this side and this is congruent to this, then I can also say, well, BD is congruent to BD. Does anybody know what that reason is?
The reflexive property.
Yep, so segment BD is congruent to segment BD. And it probably seems a little bit pointless to have to write that, but it is part of us being able to say that this stuff is congruent. So this is by the reflexive property of congruence. So based on all the things that we know here are congruent, is there any kind of overarching thing that you think we can say? Okay, that's just like given to me, but what else do I know about the shapes themselves, not the angles or the sides?
Triangle ABD is congruent to triangle CDB.
Yep. So we know that triangle ABD is congruent to triangle CDB. Now, obviously you can write them in a different order. You just have to make sure that within both triangles, they're the same, like same order. So, therefore, so the three dots that kind of are shaped like a triangle, the triangles are congruent by the definition of congruence. And that's kind of what's summarizing that I just wrote there.
What are the three?
It means therefore.
If we don't write that, we get it wrong.
No, you can write the word instead. I just do that as a
But if we
symbol.
don't write either, we get it wrong.
I mean, it's your reason, so you would at least need to say by definition of congruence to say that those are congruent. You have to put a reason, so as long as you have some way that you've written the reason, that's fine.
Wait, so is the therefore statement, is that the reason for?
That's essentially the reason for the triangles being congruent. When I actually did this problem like on my own earlier before when I was prepping for this, I was like, the very first thing I wrote was that ABD was congruent to CDB. And then I was like, technically I need to show that BD is congruent to itself first because everything else is given to you. But obviously we could say things like angle ADB is congruent to CBD and things like that as well, but we just don't need to because those are all given to us and that's not ultimately helping us prove what we're trying to prove. All right, one that's a little bit more involved. 20. We've got, well, it's a big rectangle, but it's going to be cut. And this is E, F, G, H, J, K. Why they skip I, I'll never understand. All right, so again, I'm putting on here everything that would have been given to you. Each of the corners they have listed are right angles. All right, so what do I know? I'm doing the same thing I did with the previous one, but there's going to be more things that we're writing about. So what do I know, or what's kind of maybe the first thing that you see with this one?
FJ is congruent to FJ.
Yep, I would start with that. So FJ is congruent to FJ by the reflexive property of congruence. All right, what else do I know?
Segment GH congruent to segment GK.
Okay, yes, I don't need to write that though. What about EG and KH? What do I know about those two things?
Parallel.
What?
Parallel.
Why? You're right, but why?
F and J are alternate exterior angles.
Not quite. We are going to have something along those lines in a minute, but that's not quite the reason. What do we know about two lines are perpendicular to the same line?
Corresponding.
Supplementary.
So EG is parallel to KH because if two lines are perpendicular to the same line, then they are parallel. So now that I've said that, I know that EG is parallel to KH. I can kind of look at FJ as if it's my transversal cutting through those two parallel lines. So then what do I know about the angles out around this transversal?
The right angles. They're equal to 90. They're supplementary.
What would be true about this angle right here and this angle right here?
They're congruent.
Why?
Alternate interior angles.
Okay, and then what about this one and this one?
They're also congruent to the same reason.
Yep. So I'm going to say EFJ, angle EFJ, is congruent to angle, it doesn't matter which order I do them in, FJH. And then I'm going to do the other ones. GFJ is congruent to angle KJF.
Were you not supposed to write an angle in front of FJH? Or were you?
No, I just forgot to write it. By alternate interior angles theorem. So now I know that all this different stuff is congruent. If I want, I could come over here and I could put, my little symbol things here so that I can see it. So ultimately now what do I know? Obviously there aren't triangles, but what's true about this and then this one?
They're congruent.
Yep, so I would say that EFJK is congruent to HJFG. So the trapezoids are congruent. Because everything about them is congruent. So those two trapezoids have to be congruent. All right. That was probably the hardest problem in this whole thing, so don't stress over it too much. 24. They give us shapes again and then some given information, and they want us to find the indicated values, aka x and y, or a and b, or whatever the problem's looking for. So 24, given a, B, C, D is congruent to E, F, G, H, so they're two trapezoids again. Find the values of x and y. Obviously, I did not do a very good job, oh, that's really low, of drawing these the same size, but just disregard that. Alright, so I have these two shapes. Obviously, they're supposed to be congruent, minus the fact that I can't draw very well, so I never took art class. So, what do I know has to be true about this then? Okay, that was stated. Trying to solve for x and y. How am I going to go about doing that?
D and H are right angles.
Okay, D and H are both right angles, so I know those are congruent to each other. What else do I know?
28 would be equal to 4y minus 4.
Yep, so I know that A and E have to go together based on how these are written, so that means that 28 has to be equal to 4y minus 4. So I'm going to add the 4 over, so 32 is equal to 4y, divide by 4, y equals 8, so that's the y value. And then for x, I know that B and F have to be the same, so I've got 135 equals 10x plus 65. So then subtract 65. Yep, 70 equals 10x. Divide by 10, so x equals 7. So those are the two values that I was solving for. All right, use the given information to find the indicated value. So we are given that angle M is congruent to angle G, and angle N is congruent to angle H. Find the value of x. So I'm just going to say find x. Better that time. All right, so N, M, and P here, and then up here J, G, and H. And then angle M is 142 degrees, angle P is 24 degrees, And then angle H is 2x minus 50. All right, so probably the way I would start this problem is to show the things that are congruent to each other on here. So I know that M and G are congruent, so I'm going to put one of my arcs there. I know that N and H are congruent, so I'm going to put that there. So what else does that mean?
G
P
and
and J.
Huh?
P and J congruence.
Why?
The third angle theorem, I think it's called.
Yep, the third angles theorem says that P and J also have to be congruent if the other two are congruent. So basically that means I could take this value here, this 2x minus 50, and say that that also goes here, okay? And then this would be like the one we did earlier. You can either figure out what n was and then set it equal to that, or we can do 180 minus all of it. Since I did the one on the board earlier where we did 180 minus everything, or sorry, 180 was equal to everything, let's do it as if we're doing minus on this one instead. So I'm going to do 180 minus 142 minus 24 to give me the measure of angle N. And so if I do that, I end up with, what is that, 20, nope, 66, so 24, nope, 14 degrees. There we go. So angle N is 14 degrees. Okay, so then now I can say, well, angle N is congruent to angle H, so I can say 2x minus 50 is equal to 14. Add 50, so 2x is equal to 64. And then divide by 2, x is equal to 32. So, again, I could have done this one like the one I did on the board earlier when we were doing the PowerPoint stuff. I just wanted to do this one the other way so that you could see it done a different way. This is usually the way that I do it, but that's just nothing wrong with the other way. Just my preference. All right, questions on those before we move into our last problem? All right. So we've got a proof left. I'm going to have you open your books up to page 208 so I don't have to copy over this. For those of you that like to do origami, you might find this problem a little bit more interesting. But 36 through 38 all go together. We're doing the proof for 38. But essentially they are folding a piece of paper to make a kite. And so then with that information, we're going to be proving that two triangles are congruent to each other. So all I'm going to copy down as far as this problem goes for the sake of time is the given, which is that DB is perpendicular to FG. E is the midpoint of FG. BF is congruent to BG. And BD, the ray BD bisects angle GBF. And we're trying to prove that triangle FEB is congruent to triangle GEB. So obviously without the picture in front of you, you pretty much have absolutely no idea what this is talking about. I kind of skipped the instructions when I was attempting to do this one at first, and I was like, is there a picture that goes with this somewhere? And I was like super confused, and then I read the instructions and realized there was a picture. So that picture of that kite there has everything for you. So we're going to set up our proof. And this is a little bit of a longer one. All right, so basically my first step obviously is the given. Essentially, you just need to rewrite all of these things in the given spot. So I'm gonna do that first. Alright, so after I do that, I'm looking at all my information. Ultimately, like I said, trying to prove that I have two congruent triangles here. So I would look at the fact that angle BEF and BEG are both right angles. Does anybody know the reason for that?
Wait, zero.
Yeah, angle BEF and angle BEG are right angles. What proves that?
Has something to do with supplementary, right?
If two lines are perpendicular, what do we know? That it forms what? Four right angles. So if lines are perpendicular to each other, so we are told that DB is perpendicular to FG. So that's the two main parts of the kite, right, going across. So because those two things are perpendicular, I know that the angles have to be right angles. Now, obviously, I could also talk about FED and GED are also right angles. But ultimately, because I'm just trying to prove the bottom two triangles out of the kite are congruent, I'm not worried about the top part. But if you wanted to put that, you could. This is technically theorem 3.3. Or you could say, like when the book does their reasons, if it's a theorem with just a number, they actually like write out the whole thing, but you don't need to do that. You have the book for that. So theorem 3.3. So then if these are right angles, what must be true about these two angles?
Equal to 90 degrees.
I don't need to worry about that.
They're a linear pair.
I mean, true, but what's true about two right angles? They're congruent. Triangle. Goodness, triangle and angle is gonna really throw me off. Angle BEF is congruent to angle BEG by the right angle congruence theorem. All right, so the next thing then I would say is that EF is congruent to EG. What allows me to say that? And look at your given information if you're not sure.
Because E is the midpoint.
Yep. So the reason would be the definition of a midpoint. All right, so right now I know that, let me just draw this for a second. Nope, I'm gonna draw a kite for me, cool. I'm just doing this so we can look at this. All right, so right now, I know, this will work. Okay. I know that these are both right angles, which means that they're congruent. I know that this side is congruent to this side. So I need to look at the other stuff because I need to prove that all those things are congruent to find that or to show that the triangles are congruent. So what else do I know at this point? I know the stuff's not labeled. You'll have to look at yours, but what does an angle bisector tell us?
That it's a halfway point, or it intersects halfway through.
Okay, so it's splitting this angle here in half, right? Exactly. So these two things have to be congruent, but I need to say by the definition of a bisector. So that would be that angle FBE is congruent to angle GBE by the definition of an angle bisector. Alright, so I've shown that these two things are congruent here. So then, if this angle is congruent to this angle over here, and this angle is congruent to this one, what else do I know?
Other sides.
Sides or angles? Yeah. So that means that this angle over here and this angle over here also have to be congruent by the third angles theorem. So the next thing is that angle BFE is congruent to angle BGE by that third angles theorem. The bell's about to ring. We have 2 steps left. Don't nobody go anywhere. All right. Then I know that these share a side, so by the reflexive property, BE is congruent to BE. And then ultimately, I've shown that all the sides are the same and all the things. So that means that now triangle FEB is congruent to triangle GEB by the definition of congruent triangles. All right, I'm going to put your problems here at the bottom. 11, 13, 17, 19, 25, 27, 29, 35, 47, and 53. So once you write all of those down, you can go. I would suggest at some point you attempt to look back over this proof and make sure you understand it. Maybe try to go back and do it on your own before the quiz to review. Make sure you understand what was happening. The one proof that you have to do, you're just filling in the blanks, and it's much easier because obviously you're just writing in the reasons for everything.